Yes, so this is section 1. We are talking about quadratics in standard form. The cube looks crazy. Can't see? Yeah. That's the only time I let you move is if you can't see. You can't see well? I can cut the other light off.
No, I'm like blind. It's not.
Okay.
It's not.
Does anybody know what a quadratic is?
Something more.
That's a great guess, unfortunately.
4 points.
Not correct. No, it has more than 4 points. So you've graphed so far lines. You're probably most familiar with graphing lines. Quadratics are kind of a step up from lines, okay? They've got a term in them that has an x squared on it, okay? So it looks a little funny when we graph. And you know what you get when you graph a quadratic?
You get that square.
What's that called? What's that?
Parabola.
That a parabola. Good job. You get a parabola when you graph. So it looks like this or like this. And it can be skinny, it can be wide. But before we actually graph them and I show you what the equation looks like, I want to talk about some characteristics of parabolas first, okay? Because I think it'll kind of help you. You want me to write that?
Yes.
Parabola. So let's look at these parabolas, not to be confused with parabolas. Just kidding. All right, I'm going to draw 2 of them up here. Tell me something you notice about a parabola, geometric-wise.
They're symmetrical.
They're symmetrical. Definitely symmetrical. It is a U also, or an upside down U, but they're symmetrical. So I'm going to draw this line in the middle. What would you maybe call that line? A line of symmetry. When we're talking about parabolas, a lot of times we'll call it an axis of symmetry. Here and here. Now this axis of symmetry goes through a very special point. You know what that point might be called? Oh, who said it? Good job. It is kind of a center, but we call it, in mathematical terms, the vertex. I'm impressed, y'all. Did y'all do this in geometry?
She touched on it.
Touched on it a little bit? Okay. All right, so this is a vertex, and it is the critical point of the parabola, okay? And here's why. If you look at the parabola, whenever it's opening up, a happy parabola, okay? That's the lowest point ever on the graph, right? You agree? So it's a minimum point. Minimum. Whenever you're up at the very top, it's the highest point, so it's a what? A maximum. So we use quadratics a lot of times. You'll hear people talk about maximizing profit, right? Or minimizing cost. A lot of times those are quadratic functions, okay? That you can find the vertex there to find the minimum or the maximum. Sometimes we also call them a change of direction point. Because if you took your pencil and traced along the parabola, so let's look at this first one here. I'm going down, 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 but whenever I hit this point, I change directions and I start going up. Do you see that? Okay. So it's important for a lot of reasons. Does that make sense to everybody? Everybody good? Okay. So let's talk about what the equation looks like. Can I move forward? Okay. The equation for a parabola or for a quadratic looks like this. Now, the A, the B, and the C are coefficients, okay? So when I talk about A, I don't include the x squared that goes with it. It's just the number in front. If there is no A, B, or C, in other words, if it looks like x squared plus x, okay? Remember, there's an implied what in front of those variables? A 1. Okay? Here, C would be what? What could I add to keep the value the same? 0. 0. So in this particular equation, A would be 1, B would be 1, and C would be 0. Does that make sense? You got to talk to me.
Yes.
Okay. Are we busy copying and that's why we're not talking? Tell me to slow down if I need to. Let's talk about some characteristics of the graph before we actually graph it. Characteristics. Big word for a math teacher, huh? I did good. Characteristics. So when we look at the equation of the graph, which remember, and I'm going to make this y equals this time, can tell us a lot about the graph without actually graphing it. So the first thing I want to look at is that A that sits in front. Also called sometimes, actually, do you know what it's called? The number that sits in front and leads the equation? The coefficient that sits in front. You know what it's called? You're going to know it when I write it. I tried to give it to you.
Leading.
Uh-huh.
Coefficient.
Coefficient. That's called the leading coefficient. So it tells us a couple things. The first thing that it tells us, if that leading coefficient is positive, so we're talking about A, I'm going to put greater than 0. Do we all understand that greater than 0 means positive? If you don't, make yourself a note in your notes. Right on there, this means positive. If it's positive, that tells us that our parabola opens up. So it is a happy parabola. Positive, happy, smiling, opening up.
Wait, what means it's positive?
If the leading coefficient is positive.
How do we know it's positive?
So you would look at the equation. If I had an equation, A equals 2x squared plus 5x minus 1. That leading coefficient is positive, so that parabola would open up. Does that make sense? Whereas if it was negative 2x squared plus 5, it would not open up. Because if it's negative, it opens down. We're just kind of, without graphing, looking at what the equation looks like and gathering some information before we graph. Yes or no? Maybe. Positive, up, negative, down. We're going to do a couple examples with all these together before we graph. Somebody on that side will have to keep an eye on the time for me whenever I need a time check because I don't have a clock on here. What's the time?
8:56.
Okay, thank you. I get caught up. All right. The other thing that A tells us a lot. Okay? Remember I told you that parabola could be skinny or it could open up wide? A tells us this, and this is where you have to kind of think about it. If A is 1, we're going to call that an average width. That's like the parent graph, okay? It's going to be a normal width from the vertex. It's going to go up 1 over 1, right? I mean, it's just average parabola. But as A gets bigger, so if A is 2, 3, 5, 8, bigger than 1, the bigger it gets, the skinnier the graph gets. So a really big A might be a really skinny little parabola. So that's kind of the opposite of what you probably thought would happen, right? Maybe? No? Yes? No? Okay. Put a line here. And then, what do you think happens as A gets smaller? Wider. And remember, when we say smaller, we're not talking about positive or negative, because positive or negative has to do with up or down. So we're kind of talking about the absolute value of A, bigger, smaller. The last thing I want you to be able to recognize from just the equation, and I'm going to give you several examples in just a minute, and we're going to walk through, is it up, down, skinny, wide, is the C on the end. What do you think, looking at the equation, the C is the only thing that doesn't have a variable hooked to it. What?
The starting point where you no, that's a different thing.
Now it's your
That's
get-
like the thing for just normal. That's the y equals mx plus b. And the
So
b-
what is the B in that equation? Because you're
B is the starting point.
not start. Well, you're starting there, but what is it? What M is the slope.
B is the y-intercept.
The y-intercept.
Oh, yeah.
In that equation, B is the y-intercept, and I want you to see why. If you have mx plus b, okay, to find an intercept, you plug in 0 for the other variable, right? Y-intercept is where x is 0. If you plug in 0 for this x, that whole term goes away. You're just left with the b. Now look at my quadratic equation. If I plug in a 0 for the x's, what am I left with? So C is my what? Good job. C is my y-intercept. I try to push y'all to make connections so you see, because I find that you understand it better when you do. But then some of you will understand this better when we do the actual examples that we go through. So don't fret if you're a little confused right now. All right, let's do a couple examples and see how you feel. Let's do 3x squared plus 5 negative 1/2 x squared 2x and let's do these three. I'll give you a second to copy them. Let's look at the first one. Before we start, let's identify A, B, and C because that might help you, okay? What is A for the first equation? 3. What is B? 0, because we don't have an x. Do y'all see that? It's missing. It's missing altogether. So if it's missing altogether, couldn't I rewrite this as 3x squared plus 0x plus 5, and that's the same thing? Just I gotta have that x term. All right, so that's B. How about C? 5. Yes, no, maybe so? Okay. So, tell me this. Does the graph of 3x squared plus 5 open up or down? Up. Why? Because it's positive. Good job. Is the graph skinnier than average, wider than average, or just an average graph? Skinnier. Why? This is bigger than 1, so it's skinny. No, we're just kind of setting up and giving you some things to help you in graphing. How about the y-intercept? 5. The C on the end is the y-intercept, yes? How about the second one, up or down? Down, why? A big old negative in front makes me go down. Skinny, wide, or average? This one's wider. Reason being it's less than 1. Remember, it's the opposite of what you think. The smaller it gets, the wider the graph gets. Tricky a little bit here. What's the y-intercept? Yeah. Good job. No tricking y'all. And then for the last one, up or down? Up. Careful before you answer this one. Is it skinny or wide? Skinnier because 5 over 2 is 2.5. It's 2.5, so it's bigger than 1. Y-intercept? -6. Good to go. How you feel about it so far? Be honest. Good. Easy. Not too bad so far. All right. So here's what I'm going to do. What's my time? Perfect. All right. What I'm going to do as we graph this, anytime I can, I try to give you like a step chart, okay, so that you can go back to your notes and go, God, I just can't remember how to graph in standard form. And when you flip back to those notes, there's a chart there that says step 1, do this, step 2, do this. So I'm going to do that for graphing in standard form, okay? So it's going to take me a while to go through it. When we get to the end of this example, understand all of your problems are not going to take you this long. I'm explaining as I go, all right? Everybody gets intimidated by this lesson because it does take a while. All right, let's do it. When we were looking at parabolas and characteristics of parabolas, I mentioned that something was very, very important. What was that something? The vertex. The vertex. So that is what we're going to find first, okay? Let me give you a general. I'm going to put ax squared plus bx plus c. Let's graph. All right, so we said the first thing we're going to do is find and plot the vertex. How are we going to do that? Well, the first thing we're going to do is we're going to find the x part of the vertex, okay? And there's a little formula for doing that. It's opposite b over 2a. Now, I know that's a negative sign in front of the b, but sometimes if we say negative b, it kind of confuses you because you think it's forcing a negative. What it's really doing is it's just changing the sign of whatever the b is there to start with. So looking at my example on the right, tell me what is a? 2. What is b? Negative 8. And what is c? So without even graphing, looking at this equation on the right, is it going to open up or down? Up, skinny or wide? Y-intercept? So I know a lot about what this graph should look like as I graph it, okay, without doing anything yet. All right, so let's find the x part of the vertex. If b is negative 8, then opposite b is 8 over 2. A is 2. So that becomes 8 over 4, which is 2. Are we in agreement? Okay. Now, let me go to my graph here. So we said for this one that x equals what? For the vertex? 2. Okay. Somewhere here is going to be my vertex. I'm going to draw this dashed line because guess what this is? That's that line of symmetry that we remember we talked about in the beginning. So I'm going to label it axis of symmetry. All right, so this, I'm going to make a note, is also the equation for my axis of symmetry.
So your x is your axis of symmetry.
Your x of your vertex is your axis of symmetry. And if you look back, if it's not too far back, come on.
Can you have a quadratic where it's the y is the axis?
It's no longer a quadratic because that wouldn't be a function. If it opened this way,
Can't be sideways?
no, it's only going to be up or down. So if you look, if this point was, say, 2, 5, here, this line would be x equals 2. All right. So we've now found the x part of our vertex is also the axis of symmetry. We've graphed that axis of symmetry, but now my question is, a vertex needs 2 parts. Do you agree? It's a point on a coordinate plane, and points have 2 parts. They have an x and a y. How do you find y if you have x? You plug in here. This equation says y equals, right? So to find what y equals, plug in what I know for x, right? Okay, so I'm going to make a note over here that says after I find x, plug in to find y. So here's where the calculations come in, all right? So you'll definitely want to utilize your calculator because you can start making some careless mistakes here. Tell me my pen is going to work.
Like a normal calculator?
Yeah, you can use, by all means, you can, all right, so y equals 2 times, I'm plugging in 2 here, 2 squared minus 8 times 2 plus 6. So order of operations, parentheses come first and followed by exponents. 2 to the second is 4 minus 8 times 2 is 16. Left to right, 2 times 4 is 8. And now 8 minus 16 is negative 8 plus 6 is negative 2. So what are the coordinates of my vertex? 2, negative 2. Does that confuse anybody? Then I'm going to flip right here, and I'm going to plot 2, negative 2. There's my vertex. I'm going to label it with a V, just so I know. So to find the next point, I need to find the easiest point to plug in that I can kind of think of. So I need to find an easy point. Now, easy points could be your y-intercept. That's easy enough, right? I don't have to do any calculations for that. That's just the number that sits on the end. But it could be that my vertex is my y-intercept, because that could happen too, in which case I couldn't use that. So I may have to pick an x to plug in. So I'm going to make you a note here that says you can use the y-intercept or pick an x to plug in. To plug in. So here, if I use the y-intercept would be 6, right? So an easy point here, oh, I put, what happened? Oh man, y'all didn't tell me I misnumbered. That's still part of the first step. 0, 6 for my y-intercept would be pretty easy. Okay. If I didn't want to use the y-intercept or couldn't use the y-intercept, then what I could do is I could say, well, I started at 2. What's pretty close to 2? Or, go the other way, 1. And 1's a pretty easy number to plug in also, right? Okay, so I might want to use this, or I could do 1 and plug that in. That would be 2 minus 8 plus 6, which is 0. Now, you won't have to do both of these every time. I just wanted to show you what would happen, because sometimes I just might get a parabola that I calculate the vertex, and the vertex sits here. Well, then that can't be my easy point because I've already used it. I would have to pick something over here to plug in. Does that make sense? All right. So let's plot it. Plot. Which one y'all want to do? 0, 6 or 1, 0? 0, 6. So 0, 1, 2, 3, 4, 5, 6. Now, all I know right now is that is a point on my parabola. Okay? The last step is the easiest. It's the most fun, too. You ready? You just reflect it over. It's symmetrical, right? You've got a line of symmetry. I call this step, it's my favorite. You get a different color. Well, reflect and connect. It rhymes. Flip it over, reflect, and think back to geometry, how we reflect a point over a line, and you can tell Miss Wilson we're using reflection. She'll be very happy. Count over to the axis of symmetry, it's 2. So if this was a mirror sitting here, this point would occur right there. Don't make it a very sharp point there on the end. You want to kind of curve it. But that's what it should look like. Notice, had I used the other point, it was 1, 0. Go there. It's on there also. Does that make sense? What you think? Give me a thumbs. A thumbs up, I got it good. Yeah, so, I don't got it at all. Let me see some thumbs. Okay, let's do an example. Let's do one more example with it because I see some. Sure. All right. Let's do.
Wait, so the homework we're getting today, we won't have any homework on Monday.
Step 1. What is it? Starts with a V? Vertex. So to find the vertex, remember I'm doing opposite B over 2A. In my equation, what is B? I don't have one, so it's 0. Well, if I've got 0 up top, it's going to give me 0, right? 0 divided by anything is 0. How do I find the other part of the vertex?
Put it into the y equals.
Put it in the y equals. Does that confuse anybody?
Wouldn't that just be y equals 0?
All right, so A is 3, B is 0, and C is 0. You with me? Go ahead, what?
It would just be 0, right?
Correct. 0, 0.
So that's first new vertex.
Uh-huh. Yep, is 0, 0. Also, it's my axis of symmetry. So now, and I did this one because I wanted to do one where you couldn't use the y-intercept. In this case, the y-intercept is my vertex. So I need another easy point. Plug in like 1. That's a great suggestion. If I plug in 1, I get 3 times 1 squared, which is 1 squared is 1, and 3 times 1 is, so what's that point? 1, 3. 1, 3. Where? 1 squared? I plugged in this original equation.
Okay, yeah, okay.
You with me? Okay. Now what do I do at that point? Reflect it. Reflect and connect. Tell me what you think.